All right, so let's get started. And the first thing we're going to do is draw a triangle. Everyone draw a triangle. 1, 2, 3 sides. Random triangle. And when we draw this triangle, yes, you can shade it if you'd like. You can go click, click, click. Construct triangle interior. And I want to make a little text box over here, and I want to write down, I'll use different font. Select the 3 vertices, construct triangle interior. And I'm going to write down here Theorem 4.1, because I remember this from Theorem 4.1, is the Triangle Sum Theorem. Now, the reason that's important is we proved back in the beginning of Chapter 4 that the sum of the interior angles of a triangle is equal to 180 degrees. Any triangle. So there we go. We're saying that triangle. That triangle has 180 degrees of interior angle measurement. Now, I'm making my triangle small because I'm going to have some other figures in there. And you see, I'm going to make this little chart here. This little chart with n and s sub I. S sub I is going to be used, a variable used to refer to the sum of the interior angles of a polygon. So I'm going to start here with the sides of 3. I know I have 180 degrees. Hey, that's kind of fun. How about if I have sides of 2? Can I have a polygon with 2 sides? No, I cannot. 3 is the lowest number. So the next thing we're going to do, I'm going to make a foragon. What's a foragon? Is there a better word for that? Quadrilateral. That sounds mo better. Now, it must be, it's a random quadrilateral, but it must be, see this word up here that's highlighted? What is that word? Convex. This is convex. If I did this, this is concave. No good. So I have a convex quadrilateral, and I'm going to draw a diagonal, just one. Even though it has 2, I'm going to draw 1. So I'm going to construct a triangle interior. And then I'm going to construct another triangle interior. Why? Because it's fun. And I'll make them different colors. You're all in Sketchpad 5, or I think most of you are, and it automatically changes color on you.
Oh, you just split them right there?
You're splitting this quadrilateral into 2 triangles. Now, what you've probably noticed, since we've said this before, I know this is also a triangle, has 180 degrees of interior angle measurement. So does the green one. So that means that if I take this angle and the angle formed here, and this angle over here, wait a minute, this angle, this vertex, you all see this vertex? This angle is composed of this green angle and the purple angle. By angle addition, since this 180 is spread out on the 3 vertices, and this 180 is on the 3 vertices, I can add them together. So this foragon, also known as a quadrilateral, does not have 180 degrees of angle measurement. It has 360 of internal or interior angle measurement. Now we're cracking. So we're going to go for a fivagon. I need a good name for that. Pentagon. I like that. And remember, this is convex. If I put a lot of snow on the roof, watch this. It caves in. That's concave. That's no good. I want convex. So I'm going to draw not 1, but 2 diagonals because I want to split it into 3 triangles. Oh, this is fun.
Yeah.
Well, see, you're going to learn. You learn by doing, not by watching. So this triangle has 180 degrees of interior angle measurement, as does this purple one, as does this green one. And this figure, as we said, is a pentagon. Well, don't worry. If you can't keep up, you can always fill in the gaps and play back the recording. But you'll get a minute to go back to it, fill it in with your friends. Five sides. How many triangles?
4.
3. 180 degrees each time. So 180 times 3. Now we're going to do one more, and then we'll try to use our skills, our mathematical induction skills. Let's go with a sixagon.
Hectagon.
Is a whatagon?
Hectagon.
Hecta? Well, that's close.
What?
It's a hexagon. Now I'm getting tired of shading it. I'm going to leave 2 triangles white like that.
Oh, how do you shade it again?
You select the 3 vertices. Click, click, click. Construct polygon interior. Well, it looks like 6 sides gives me 4 triangles. So 6 triangles, or 6 sides, sorry, 4 triangles, 4 180s are 720. Now, we could keep going on and on and on, and that would be boring and boring and boring. Or what we could do right now is try to find a general case. If I have n sides, where n is a variable. Now we're going to develop something right here. I'm looking at n. All right, on the simple triangle, n is how many? What is n on this figure?
180.
What is n? 3. How many triangles are there?
1.
1. What is n on the quadrilateral? 4. How many triangles? 2. What is n on the pentagon? 5. How many triangles? 3. So, what's the relationship between the number of triangles and the n? N minus, I didn't say anything about degrees. I said triangles. N minus 2, thank you. If there are n sides, there are n minus 2 triangles. Do you all agree with that? Can you see it? See 5 sides, 3 triangles. 6 sides, 4 triangles. So 20 sides, 18 triangles. Each triangle has how many degrees of interior angle measurement? No, how many degrees in each triangle? Triangle Sum Theorem 180. So you've just developed the formula. There it is. Now this is what we refer to as mathematical induction from section 2.1 of your textbook. Mathematical induction. So the last thing you're going to do is write down right here. Well, the operation is induction. You can write that down if it helps. I'll write it down. There's S sub I. Hit the right arrow, it kicks it out of that subscript form. And I'm going to write this formula. N minus 2. You just developed this formula. Isn't that beautiful? Times 180. And I'll make that a little bit.
Wait, how did you do the subscript?
The subscript is inside the text box here. When you click here, it's down here, right next to exponent. S, the sub I, S stands for the sum of, the subscript I, the interior angles of a polygon. Our former textbook used this, and I can't believe anybody has time to look at a cell phone. Luke. Use the forks. Now, this operation, this process is called mathematical induction.
I don't get how you put the 1 like that.
Don't. If you're stuck on little things, those are details. You can fill those in later.
S1.
Just S sub I. It's not a 1. It's a subscript. Now, you also haven't been here for a whole semester, so I don't expect that you can keep up, but I can't slow down to your speed. You have to get some help.
There we go. 180.
All right, and we're going to, since most of you are done with this page, we're going to the next page. Next page, really quick, chop, chop. I want you to go down to the custom tools. There's no slack-a-lack in here today. Go to the next, go to the custom tool and draw a ray. Then click, hold it down, draw another ray, and another ray, and another ray, and another ray.
How many rays?
I don't know. I think I did 5. 1, 2, 3, 4, 5, and loop them all so they come back together. Oh, I'm sorry, I did 6. Does it matter? No. I'm going to call these, I'm going to put a little 1 out here. Because angle 1 is what we call an exterior angle. I could label all these 1, 2, 3, 4, 5. I could say angle 2 is also an exterior angle.
How many rays do you
I don't care.
Okay.
Because you could also do this. I could make the same, I could make a figure with more sides like this. As long as I make it convex. See, if I do this, it's messed up. No concaving. Convex.
I don't get how you did that circle so cool.
Skills. You got to have skills in this class, Luke. Use the force, man. You got to use it.
I gotta figure out how to do that.
Now, I want to point out that every vertex, if you want to, you can shade one of these figures, just one. In this case, I'll shade my hexagon.
You want us to do 2 figures?
No, I want you to do 3. It only takes you a second. Now, that's the shaded is the interior region. The 1 and the 2 are exterior angles. I could do this. Notice I could put a ray this way. Now, I just want you to watch it, and I'm going to color this ray a different color. Now, angles 1 and 3 are vertical angles, right? And they're both at the same vertex. In our textbook, we are concerned with 1 exterior angle per vertex. 1. So, as you can see, you get that just by extending the side. So here's your formula. This is really neat. You don't need to memorize. Well, no, you need to memorize this, but there's no calculations. The sum of the exterior angle in a convex polygon is always equal to, are you ready? Drum roll. Where's my drum roll? All right, there you go. Ready? Oh, yeah. That's it. 360. The sum of the exterior angles in the polygon, that's 1 per vertex. So this orange one doesn't count. 1 per vertex. So, in general, can anybody make a generalized statement? If I start to add a lot of sides, what happens to the exterior angles? Right, they're always going to equal 360, so that they have to be getting smaller. Now, there can be an exception for like 1 or 2 angles, but for the most part, this is true. That is, exterior angles, they always add up to 360. Doesn't matter how many there are. Now, we're going to take that fact and move on to something more interesting. Next page. Look at that. We got some momentum. I want you to take on the side here, we're going to do a little calculation and we don't even know why. But I want you to take the number 360 degrees, and I want you to divide by 5. I want to see who's got the skills, who's got arithmetic down. How many 5s in 360? Or in other words, what's 360 divided by 5? Don't use a calculator.
60.
5 goes into 35. How many times? 7. Then there's 10 to 10. 2. There you go. 72. Done. Now just hang on to that thought. It's good to know that. You don't know what you're doing with it yet, but just hang on to it.
Wait, isn't that the
Yes.
is that the count of like, the measurement of each exterior angle?
Well, we're getting to that. Now, I want you to double click on your A right there. You got to mark A as the center of rotation. Now, if you grab B and move it around, you'll notice you can resize. This thing jumps all around, but it's relative to A. This ray. Whee! Oh, that's so much fun. Ready? Take your select tool, sweep, and select. Select the ray and point Charlie. And then you can go to Transformers, rotate. But I don't want 90 degrees. What do you think I want? 72. That's a good idea. Let's try that. Now, I have to tell you, it's not until we hit chapter 10 when we learn about central angles. That's really what we're using here is a central angle, which is invisible to us right now. But it happens to be the same as the exterior angle. So watch this while it's still highlighted. Rotate. Boom, shagalaka. Do it again. Do it again. First and 10. Do it again. Woo. Oh, this is the funnest lab ever, EVER. You could shade your pentagon. This pentagon is different than the last pentagon. This is a regular pentagon. And a regular pentagon is equiangular and equilateral. Accent on the equiangular. And yes, you can move it around and do all these fun things. Woo, woo, fun, fun, fun. But once you start adding dummy text to it, you can't really move it around. So I'm going to write down, I'm going to leave this right here, this 360 divided by 5, and I'm going to write 72 all the way around here. I'm going to write the number 72 degrees because this one's 72. I'm going to cut and paste. That one's 72. That one's 72. And that one's 72. Now 5 72s are 360. So that's what we done did. We done did it. Now, you see how it's so much better when you go fast. If you go slow, you get bored. I'm looking for an interior angle here. What's the relationship between the interior angle and the exterior angle? And it rhymes with linear hair. They're a... Oh, gosh, you guys are on it. So, what would be the measure of this angle in here? How much?
180 minus 72.
Which is 108. Oh, yeah. So, I know that each of the interior angles, since they're all the same, must be 108. So, I've got 108 there. I've got 108 there. Here, 108. There, 108. Look at that. I've got 108 everywhere. And it's faster if you just cut and paste. Or make copy and paste, I mean. So now, one more thing before we flip the page. I want to do a little arithmetic. Try this. I want you to take all those blue ones, take 5 times 108 degrees. Now, no calculators. What's 5 times 1, everyone? 5. What's 5 times 8? 540. Done. Now, the total number of interior angles of this pentagon is 540. Flip back 2 pages. Boom shakalaka right there. Oh, look at that. Now, so Mr. Banish, could you not have just taken the 540 and divided by 5 to get the 108? What about that? What do you think of that? Yeah, I could have done that. I could have done that, but it's easier. It's usually easier to take the exterior angle because you're always dividing 360 by n, regardless of the size of the n. Oh, you're going to have so much fun doing your homework tonight?
You always divide by 5.
No. When you have a regular pentagon, you always divide by 5. A regular hexagon, you divide by 6. We're talking about regular n. You divide by n.
Bond. James Bond.
James Bond, here we go. You've got something called the center. I want you to double click on the center to mark it as your center of rotation. And you've got this point alpha, which I put stops on it. It gets smaller, gets bigger and smaller right around there. So you've marked the center by double clicking. Select the point alpha. Go to transformers. We're going to rotate, but not 90. Give me a number that's a it's 30. All right, I've got 360 degrees
45.
divided by, and I want 36 divisions of 360 degrees. 10. Now you could use this ray tool, but you won't get the full bond effect. You need to hold this down and select this tool. Get the stock ray tool, the big ray tool. So it goes like this, goes wah, like that. Oh, everybody got that? And I'm going to make it black. Oh, it will. Hold it down. Hold this thing down. See? And then you can select between ray and segment. Second one, which is ray. And draw the ray from A to your rotated point. Now, you've already marked the center of rotation. So now I want to select the ray and this point. Transformers, rotate it again, 10 degrees. Transformers again, rotate it 10 degrees. You got to do this 36 times. Well, you don't. That's if you want to be slow. If you're smart, let's suppose you did it 3 times, then I'm going to reselect. And I'll not, instead of rotating by 10, I'll rotate by, hey, how about that? 30. Now I can select them all and rotate by. And now I can select them all and rotate by.
That looks so sick.
Sick. Yes, that's the word we were looking for. Bond, James Bond. Remember that? Oh yeah, right? So while you guys are clowning, while you guys are trying to catch up, I'm gonna have some fun here because Sketchpad is all about having fun.
How do you do that?
Just keep rotating. See now, I'm gonna color. I'm doing a little coloring here.
Wait, how'd you do like that many, like at a time? You selected them all?
Yeah.
Well, I keep on doing that. It's only showing me one of these.
Because you got to change the amount that you're going to rotate by. Well, that's not the right color.
I've got to change the amount.
Oh, there we go. There we go, everybody.
What do you
Yeah, every time the
How did you do that?
All right. So there we go. GoldenEye Bond.
I do multiple at a time.
Wait, how did you do it so quickly?
Okay. We're all getting bored. It's time to move on.
No, I'm not doing one.
Oh, you can come back to it. You can come back to it. All right, next page. Next page. We're burning daylight. Heavens to Murgatroyds. Not this one. This is horrible. We're going to do... I'm going to make my text bigger so you can see it. And we're going to add up all the diagonals. This is fun. We're going to call this the kitten project. Meow. Go, Lynx. I want you to start on A. Now, I can't draw a diagonal from A to A. I can't draw one from A to B because that's a side. But I can draw A to C. I'm going to set the color to purple. Because the only way I can keep track is I'm going to keep changing the colors to match my vertex. So I'll draw a purple segment. Now my segment's always purple from A to E, A to E, A and G, A and H, A and J. How about A and K? No, they are adjacent, so they don't get it. Looks like a little clamshell. All right, next one. Now we're going to go to B. BK. You guys all know that one. And I'm going to change them to red because B is red.
Oh, it's the color of the triangle.
Yeah, make it pretty. And look at that. And again, I drew, oops, I missed that one. So I drew 7 purple, and I drew 7 red. But look what happens when I get to Charlie down here in green. CA is already drawn, so I'm going to skip it. I'm going to go CK, change color to green. I'm not going to get 7 greenies. I'm only going to get 6. Then delta. Going for the orange. 1. See, it looks like a big ball of yarn. 3, 4, 5. But you'll catch up. Isn't that what the potato said to the other one? Or tomato. Sorry. I can't even get my jokes right. E. E can connect to J, K, the H, and the G. So that's looking a lot like 4. Yes, F, as in fun, F to K, our favorite color, magenta. F to J, F to H, rhymes with tree. That would be 3. So you see this pattern is going to continue until we've drawn all the possible diagonals.
Wait, what are the numbers down there?
That's the number of these that I can, the number of diagonals I can draw from that vertex. So I'm trying to, without repeating.
She only has like 6.
When I get up to H, there's only 1 diagonal left.
How come?
Well, because all the ones are already drawn. Do you see that?
Oh.
So you've connected every point. When I get to point J, all 7 diagonals connecting it are already drawn, so I can draw 0 fresh ones. And silver K, I got none there. So I'm going to add this thing up, add this bad boy up here. I've got 7 and 7. Say it out loud. 14 and 6, 20 and 5, 25 and 4, 29 and 3, 32 and 2, 34 and 1, 35. So this decagon has 35 diagonals for this convex irregular decagon.
This is tripping me out right now.
Oh yeah, it gets better. All right, we're gonna
Wait,
say.
how many diagonals does Pentagon have?
Well, it's funny you should ask because we're going to see that on the very next page. All right, if you didn't finish this, that's okay. You can come back to it. We got to go to our last page. This is our induction page. When we come up with a general formula, I think we haven't finished this in any class yet. Now, this is different than chopping this figure into triangles. See, there's 2 triangles, but if I drew all the diagonals, I could draw 2. To make it easier, I'm drawing regular figures here. not irregular figures. So 4 sides, 2 diagonals. But this is going to be a little bit trickier. A pentagon. Wait a minute. I'm going to draw 2 right there. Then from here I can draw 1, 2. So now I got 4. And now to complete the pentagram, I draw the remaining diagonal.
Do we have to color all one? Isn't that like a Demon Star or whatever?
Yeah, do you want the lines different colors?
Now, I like to change them at the vertex. You don't have to, because it's easier to keep track of them. And that's going to be 5. So it looks like the pentagon's got 5. So this pattern's going to get a little funky. Now you already know, because we did on the last page, on 10 sides, on 10 sides we know we have 35 diagonals. Let's just going to do the 6, and then I'm going to show you the magic. And you could change colors or not. There's 3. 4. 5. 6. I'll change, then I come here 7.
Oh my gosh.
8. But when I move up to the last vertex, there's only 1 left, and that would be 9. So how many do you see there?
I don't even know.
9. Yeah, it's hard to keep track of what you're actually seeing. All right, who wants to just see the, let's just jump right to the magic trick. Ready? Because this is really unnecessarily hard.
This is unnecessarily hard.
So let's make it mo easy the way you like it.
There we go.
I'm going to enlarge the figures. If you make one bigger, you make them all bigger. You can move them from the center. Well, I thought you could move them from the center. Yeah, so you can separate them by moving them from the center. But we're going to do the octagon. I'm going to show you magic. Just do all the, pick a stylish color from one vertex. I'm going to go with red because it rhymes with Fred. There's 1, 2, 3, 4,
Okay.
5. Now, unlike the last times, we're only going to draw them from one vertex. And I think we're going to go right to our induction. So I have n sides. I had 8 sides. I could draw 5 because I could draw a diagonal to every vertex except to itself. That's 1. And except to its 2 adjacent neighbors, 2 and 3.
So
n minus 3. Very good. So I'm going to start by saying n minus 3. That's how many diagonals I can draw from one vertex. Now watch this. I'm going to put in a circle. Draw yourself a circle. Put a magic point on the circle so it rotates. See that? All regular polygons are inscribed in a circle. We haven't gotten that yet, but that's okay. Now I'm going to label my points so you can keep track of what I'm doing, but you don't have to label them. This says A prime. I'll make the text mo bigger. I'm going to call this A, and I'm going to call my free rotating point, it can't be A. I'm going to call it C. And I'm going to label the point in the center B. So I want you to mark an angle, A, B, C. Go to transformers, mark angle. Blip. Oh, isn't that beautiful? That was so much fun, I'm going to do it again. A, Alpha, Bravo, Charlie, A, B, C, transformers, mark angle.
So you can just make a random point.
A random point, so it's free to rotate.
How do you do that?
Now, select the 5 segments and rotate them by marked angle. Oops, cancel. I forgot to double click on B, center of rotation. Rotate by marked angle. And while I'm going to make them, let's say, chromatically opposite. I'll make them blue. So here's the whole point. And we're going to finish this up quickly before the bell rings. I can draw n minus 3 here. I can draw n minus 3 here. N minus 3 here, 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 and here. Except when I do that, I'm going to start repeating. Do you see that? I'm going to start counting them twice. How many vertices does this polygon have? Well, it's got 8. But if it's got n sides, it has n vertices. Now, if I do this method, I'm going to double every one of these. So this is my formula. All I've got to do is take this, divide by 2, and that is our mathematical induction. N times the quantity n minus 3, all divided by 2, tells me how many diagonals. Now let's check this out. Take this to the previous page, and I'm going to write D equals. I'm going to take this to the previous page and see how it checks out. I had 10 sides. Wait, hang on. 10. 10 minus 7 is, or 10 minus 3 is 7. What's 10 times 7? 70. What's half of 70? 35. Boom, shakalaka. You're done. Save this and we'll, remember, come in ready for happy test tomorrow.